All right, so let's talk about this first lab here, binary games. If you've taken my classes, you've seen it before, but everybody needs to know binary, especially forensic examiners need to know it. You need to know binary and hexadecimal. So you play these games until you get a flag, and then you submit your assignment here. You put in a screen image of the flag, and you type the flag into the comments field. So the games are here. If you don't know your binary, you should learn it. So there's 3 lessons here with 4 games to play. Nibbles are where you start with binary, and so nibbles are short series of bytes. So the first thing, if you think about normal base 10 numbers that we use all the time, if you write down 147, there are 10 possible digits, and you know that 1 means 1 times 100, 4 means 4 times 10, and 7 is 1, so you get this number, 147. And you could write that as 1 times 10 squared, plus 4 times 10 to the 1, plus 7 times 10 to the 0, and that's the mathematical expression of what these places mean. This is the 10 to the 0 place, this is the 10 to the 1 place, the 10 to the 2 place, and so on. Now in base 10, you have ones on, then tens, then hundreds. And there would be thousands and 10,000s if you had more digits. So in base 2, you have only 2 possible digits, 0 and 1. So if you write 1, 1, that means 1 times 2 plus 1, which is 1 times 2 to the 1 plus 1 times 2 to the 0. So this is 3. And so a 3-digit number in base 2 looks like this. This is the one on the right is the number of 1s. The next digit is the number of 2s, and the next digit is the number of 4s. So this number is 5. It's 4, no 2, and 1. So 4 plus 1 is 5. So you can count to 7 with 3 bits. 0 is 0, 1 0 is 2, 1 1 is 3, 1 0 0 is 4, that's a 4 and nothing else, and 1 1 1 is 7, that's a 4, a 2, and a 1. And if you have 4 bits, you have what's called a nibble, half of a byte. So there's 1s, 2s, 4s, and 8s, and this is the number 9. 1 8 plus 1 1. So these are all the nibbles. There are only 16 possible of nibbles. And there they are. Going the 1 1 1 is 7. All ones is 15. That's 8 plus 4 plus 2 plus 1. Here's one that's easy to remember. 10 10 is 10. It's 8 plus 2. And so those are nibbles. And then you have a game you play to practice using them, which is this one here. So 0 0 0 0 to decimal, well, that's 0. 0 1 0 1, that's a 1. No 2s and a 4, that's 5. And this one is 15, where they're all 1s. So when you get 10 in a row correct, a flag will appear. Then you capture a screen image showing the flag, and you submit it here. Start the assignment, upload the file to upload your image. Collect all of the flags first, although you can do part of this now and come back and do part of it later. And that's where I should mention the most important thing here. I modeled this after the Khan Academy, which is the right way to teach math. You don't bother doing another lesson until you've really got the one before it. So you have to get 10 in a row right, then you're ready to go to the next lesson. And one thing that's usually good is only do one of these per day. Anyway, so after nibbles, you do bytes. Bytes are just the same thing with 8 bits. So if you go down here, 4 bits make a nibble, but 8 bits make a byte. You have 1, 2s, 4s, 8s, then you have 16s, 32, 64, and 128. So it gets a little tedious. So this number is 128 plus 16 plus 8 plus 1. So that's 153. And so there's a couple of games where you practice that. And the last one is hexadecimal, which is what you're mostly going to see in practice. And that goes like this. Hexadecimal is based on the nibbles. What you do is you take the counting to 15 that we had before, and you replace the base 10 with base 16, one character. So 0 through 9 are the same as base 10. And when you have 10, you use A, and 11 is B, and so on. So now you have one character from 0 to 9 or A through F that stands for a whole nibble. So now you can do this much easier. Every byte is 2 hexadecimal characters. You have a left nibble and a right nibble. So this number is 99 in hex. 99. And the left nibble, you multiply by 16, that's the number of 16s, and the right nibble is the number of 1s. So it's a much easier way to go from binary to decimal through hex, and that's why it's used universally by Wireshark and direct hex viewers like HXD to view data on a disk, and IDA Pro, and everything. Everything that shows you raw data is almost always using hexadecimal for this reason. So it's good to have a little practice in those things, and that's your first project here.